Primary control level loop for field engineers. Construction elevation control basics. In this video, I'm going to talk to you about level loops, or level circuits is what a surveyor might call it, as it relates to primary control. So let me start out by saying that primary control is permanent and it surrounds the job site and it lays out everything within. Secondary control is something like a baseline that controls the building and it's semi-permanent, and then working control would be like after grid lines, laying out a wall or a column and laying out the actual column or wall lines or the offsets for the wall or the column, meaning it's component specific and it's temporary. So primary, secondary, and then working control. We always have those different types. In the last video, we talked about if you have your basis of bearings that might be out on the roadway here and you want to build a building, let's say that we're just looking at the foundations and the slab on grade, that you will create points in your site, and these points will surround the job site like we talked about, and they will be permanent. And what you'll do is you'll take distances and angles and connect these, okay? So we're on the same page, and then you will have a complete network, okay? So from there, if you're gonna go ahead and lay out a baseline, and I'll just do little dots, you would, for instance, set up here, backside a longer backside, and I'll just do dots, and you'll radial stake from that point. Then you'll do it from another side of the traverse, set up here, backside, and then what you'll do is you'll radial stake that one and radial stake that one, and then you might set up here and backside a longer backside than your foresight, and you will lay out that one and you will lay out that one. And what happens is the points at the end are now laid out, and it's a beautiful thing. And then you can do a forward and back for your baseline and do direct and reverse shots to establish your distances. And so you have a really nice tight control network. Now all you have is basically your northing and easting for each of these. I won't draw this in every point. Your northing is your Y and your easting is your X. And I'm using civil coordinate geometry basics. You might run from the X axis, but in survey and in civil, you go from the Y axis 360 degrees around the circle in 4 different quadrants. So you have a northing and easting, but you don't have an elevation. But one of these bases of bearings, these monuments inside of the roadways, will likely have what I call the design benchmark. That means the benchmark from which the surveyors working for the design team took as-built elevations of the adjacent roadways and the sidewalks and the topography of the site for the purpose of designing the building. That means the building is based on that benchmark. Let's say it's right here. What you want to do is level loop. And a level loop has a couple of key things. Number one is you are going to do what's called 3-wire leveling. Number 2, you're going to estimate to the nearest thousandth. Number 3, you are going to close your level loop. And here's how you do it. You take a calibrated, well-functioning automatic level with the proper specs. And what you'll do is set up and you'll pace forward to this point and then back and then get the exact middle. You don't have to go all the way back on the second. And you will set up your automatic level and you will come sight your level rod, and you'll take your benchmark plus your backside, which becomes your instrument height, and you will come over here and you will shoot to your foresight, and that instrument height will be minus your rod height, will establish the new elevation of this point, but not yet. And so let me make this point that you will backside, foresight, all the way to your original point. And what will happen is that you will, in a nice format in your field book, log each of your elevation shots. Now here's the deal. When you're doing these shots, inside in your scope, you will read your top number, your middle number, and your bottom number. Those other horizontal crosshairs are called stadia hairs. They're used for 2 different purposes. One is you can take the top reading minus the bottom multiplied by 100, and that's how far away from your rod you are, which is really cool how they did that. The other thing it's for is if you take your top, middle, and bottom, add them up, divide by 3. The average should match your middle rod reading, or else you read the rod improperly. I don't know about you, but I don't want to go traverse a massive 200-acre site only to find out I made a mistake here. I'm going to 3-wire level as I go. The other thing is you're not going to get good enough numbers to be accurate by the time you close if you don't do that. The other thing is you're not going to read these as the nearest hundredth. You're not going to be like, okay, 252.02. No, you're going to be like 252.023 feet. And somebody would be like, well, Jason, you're guessing on that third number. But if you round up to the nearest hundredth, you're intentionally guessing to the wrong number. So if you guess to the right number, that's much more accurate than rounding. So you're going to estimate to the nearest thousandth and you're going to close back. Now what happens when you put this into an Excel sheet and you actually look at your linear error of closure and it's within the tolerance, you can then adjust the elevations ever so slightly around this thing to match and to close that linear error of closure, or that vertical error of closure, what you could also call it, as long as you're within the tolerance. Now, in the third version of the book, the Construction Surveying and Layout on page 716, I just had that memorized over the years. There's first, second, and third order accuracy depending on your acreage that will give you a little mathematical calculation to tell you how far you can be off when you close. If you're within that tolerance, now you have elevation on all of these points. In addition to your northing and easting, you have your elevation. And the reason you need your elevation is because you want to reference it for any additional control. And if you ever want to bring in another benchmark inside the site, like let's say I want a temporary benchmark in here, you will go back site, foresight, okay? Then you'll do back site, foresight, include 2 benchmarks in that level loop from known elevations and close, and only then can you know the elevation of your new point. You cannot just do a side shot and spray over there to it. So this level looping is how you get elevations on your primary control, and then how you would later bring it in through this process to your secondary and working control. Level loops are covered in detail in chapter 7 in the third revision, and I will link that to you in the description below. Also give you a blog post on this. Also, this will become a chapter inside our new book, Elevating Construction Field Engineers. If you have any questions, let me know. But level loops or a level circuit is crucial to the establishment of primary control. I hope you've enjoyed this video. On we go.